All right. Thank you so much for your attention. Our next speaker is a guest who's traveled quite far. This is Dr. David Welch. He is the head of the Kintama Research. Let's go find this. President of Kintama Research and Chief Architect of the Pacific Ocean Shelf Tracking Project, which has formed the basis of the global ocean tracking network based in Dalhousie University at Halifax, Nova Scotia. He has a BS in Biology, Economics, University of Toronto, and a PhD in Oceanography. He is an author of 250 primary scientific pages and technical reports. Would you please welcome Dr. David Welch.
Thanks, everyone. It's a pleasure to be here and an honor to be allowed to speak at your symposium. I've got laser pointers. I just
Right.
So I got into this a number of years ago, as you can tell from my gray hair. But the particular work that I'm going to talk about right now, some of it stems from a frustration I had. A group of my colleagues, 68 of them, wrote a letter. They'd all recently retired, and they wrote a letter to the various governors, state and federal senators and Congress people for the 4 states, saying the time is in now. We have to take the 4 Snake River dams out because everything else that we've tried to improve survival hasn't worked. So it's obvious that the time is now to take the dams out. And I got really frustrated when I read their very well written letter, because they didn't mention ocean conditions and the effect that the large changes in climate that have had on salmon populations up and down the west coast. So from a very narrow focus, looking just at the Snake River, they said, everything we've tried hasn't worked to improve survival beyond 1%. It used to be 4% in the 60s. So they said, obviously the dams went in the late 60s and 70s, salmon populations in the Snake River dropped. It must be the dams that caused the problem. But in fact, if you look more broadly up and down the west coast of North America, for Chinook salmon and steelhead, exactly the same phenomena has happened. It's not just the Snake River populations that have had this problem. And there's a problem of selective data. People think they see a problem that they assume is due to the dams, and then they go out and they find data that fits the belief, and this is my argument, rather than looking at what's actually possible. So I'm going to take you through my letter. I wrote it back to the same mailing list, and I sent it to my colleagues, a group of 68 of those that I had email addresses for. I never got a response back from any of them. So it's been very difficult to have that sort of open debate that I think we need to have. The key point here is the direct impact of the dams on survival is now very low. It's not zero. Speakers have mentioned 98% survival per dam project, for example. That's not 100%, and people say, well, if it's not 100%, you can't, it's not good enough. But here's the issue. The top row here shows the current smolt to adult return rates, which is 1.1%, I'm going to need my laser pointer here. I'm going to take you through the logic in my letter to the governors. The current SAR, or smolts out to adults back, is 1.1%. So I'll just call it 1% for simplicity, but the average is about 1.1%. And if you breached the 4 Snake River dams, you would raise that 1.1% to 1.3%. there's the basis for the calculation. If you took out all 8 dams, including the 4 main stem dams down to and including Bonneville, you'd bring the smolt adult return rate up to 1.5%, not the 4% that people want. And if you sterilize the river, so you killed all of the predatory birds, all the predatory fish, and somehow wiped out all of the diseases of the fish, it would bring the SAR to 2.1%. So that's the very bottom level of the recovery goals that have now been accepted by the Northwest Power and Conservation Council as the goal. The goal is supposed to be 4%, minimum 2%, maximum, or top end 6%. So it's basically impossible. So here's the 2 to 6% range, the average of 4, and it's pie in the sky to do this because ocean conditions have changed up and down the coast, and nobody is factoring that into the calculations. You know, they've assumed that they can do this. Now, I would agree with my colleagues that I'm criticizing here. We can increase SARs because the dams do kill some fish. In fact, it's much higher than this 1.3% because of probably total dissolved gas issues that some of the speakers have alluded to. But the direct impact of taking out the dams would be very modest, and of course there's economic consequences for removing the dams, plus they don't produce greenhouse gases as they produce power. So this was the background. My frustration with this is when I try to engage my colleagues, professional colleagues, in this to have a debate about this, nobody wants to debate it. They say, well, it's already obvious what the result is, or what the conclusion should be, and there must be something wrong with your calculations. So this is the starting point for my talk today. I'm going to step forwards now. In 2022, a number of authors wrote a paper called A Review of the Potential Conservation of Fisheries Benefits of Breaching the 4 Snake River Dams. Now, this paper became a big part of resolutions to remove the Snake River dams by 3 groups within the American Fisheries Society, which is a professional association of fisheries biologists. I'm a member, Canadian member. Oops. All right. So initially it was the Washington, D.C. chapter made a resolution in favor of taking out the dams. The International Fisheries chapter made a resolution in favor of taking out the dams. And then the Western Division. And then the American Fisheries Society Governing Board in January of 23 also made this same resolution. Now, I want to address this paper directly because it's an excellent paper listing the reasons that they think that the dams should be removed. But it's very one-sided. So here's the quote. The effects of the hydro system can be manifest in reduced ocean survival and ultimately rates of adult returns. So what they're saying here is that the direct effects of mortality due to the dams that I pointed out in that very first slide are small, but a lot of fish die in the ocean because of delayed mortality. They're damaged by fish passage through the dams, and then they go out in the ocean and they die, not just because of ocean conditions, but because out in the ocean, the injured fish are eaten by predators. That's the argument. Snake River populations in particular are likely impaired by substantial delayed mortality in the marine environment because of out-migration experiences. These are all peer-reviewed papers by the same authors as the storage that are in the storage stall. And I want to point this out. We note this manuscript underwent a full and thorough internal review process as prescribed by Oregon Department of Fish and Wildlife publication policies. So it's a very clear statement of professional opinion by a number of people. And essentially what they're saying is that while the direct effects of the dams are small, the indirect delayed effects we believe are very large, and therefore taking the dams out will improve the ocean survival. Well, let's look at what a review article is. Taylor and Francis is the publisher of the American Fisheries Society journals. These are the peer-reviewed science journals. Review article is a survey of previously published research on a topic. It should give an overview of current thinking. Why write a review article? Provide a comprehensive foundation on a topic. Explain the current state of knowledge. Identify gaps in existing studies for potential future research. And to highlight the main methodologies and research techniques that are used. So this is what a scientific research, reviewed paper is supposed to do. It's supposed to survey all of the scientific literature. You saw in the previous slide, these are the types of papers that they're citing to support their views. Well, John McKern was involved in this with some work that I was doing up until 2011. We looked at the the delayed mortality theory directly. None of this was cited, but it's relevant because the delayed effects of the dams, I'm going to skip the mathematics here, have to be 8 times the direct effects for people to achieve the survivals that they actually claim that they're going to get from dam removal. Now, unfortunately, because I don't have control with my laptop, I can't run the animation, but basically, this slide was going to show you the fish that we surgically implanted with acoustic tags and allowed them to go down the river and up the coast, and then where all of these red locations are, we put acoustic monitoring arrays across the continental shelf and in the river to measure survival, movements and survival. And basically for each of these fish that we surgically implanted, we allowed them to go down, pick them up, and we got the date and time that they passed each of these arrays and which fish made it, which fish did not. So that allowed us for the first time to measure survival directly. So we measured survival in the hydropower system to Bonneville Dam, from release in the Snake River, and also release in the Yakima, that I'll mention later on. The lower river and the estuary, which is where the barge releases fish just below Bonneville down to here. It's about 120 miles. And then we have the Columbia River plume, where the river runs into the ocean here, to this array, which is just at Willapa Bay, just north of Astoria. And then up to the northwest tip of Vancouver Island. We also have a series of arrays in here. None of the Columbia River fish go in here. And if I could run you the animation, you'd see that they get picked up here and then they carry on all the way up to southeast Alaska. But from release here down to Bonneville and then out to sea, it was about a month to get to here, and it was a month to get up to here. And this is about 2,500 kilometers, or about 1,300 miles to go from the release point up here. So, this part I can show you. So, we're going to break the survival down into 4 areas. And what's important to mention here is that the Yakima River, which I'm going to go back into in more detail in a few minutes, has much higher survival by the time the adults come back than the Snake River populations. And those in favor of taking the dams out, this is the key evidence in favor of delayed mortality, because the survival of these fish by the time they come back as adults from the ocean is 3 to 4 times the survival of Snake River fish. The Yakima comes right in here, near the confluence with the Snake. So my colleagues argue, well, it has to be the dams because everything else is the same. And I'm actually a marine biologist who works on salmon. I go, well, everything else isn't the same because the ocean is not one big homogeneous area. And if salmon go to different parts of the ocean, they could experience different survivals. And when I got into this originally, I knew that I needed to get involved in this because one of my colleagues who was arguing against this says, well, I can't imagine that's the case. And I said, well, you don't have a very big imagination, do you? So that was the basis, and that's sort of how I ended up spending the last 25 years working on these types of problems. So what I'm going to show you is the evidence about whether or not delayed mortality is large, which you just saw from that review paper said it's very large. So if I could show you this animation, it would run down here and up here. They are on the company's website, so if people are interested in following this up, the publications are there, so you can access them. The animations are on there, so they can be freely run if you wish. But I can't. Oh, my goodness. This one runs. All right. So these are the dots. So these are the different populations that are running out over the array. There's a clock here, and this is 2008. This is one of the years, and you can see that by August the fish are already up here. I'm actually going to step it back since it does run, and I'll run it through again. So I didn't think it was going to run when I moved it over on my flash drive. So here's the locations where we're tracking the fish, this time in magenta. You've got the various release groups that we've got. There's barging and Snake River, and then Yakima River population. So we're doing this as a treatment control group, like clinical trials for drugs. One group goes through the 4 Snake River dams. The other group, the Yakima, goes through, comes in here, and we timed them so they went out to sea at the same time, or went into the river at the same time. At this point, meet together, and then they go out. And so here's the Snake River fish coming down. The Yakima fish are coming down. The colors are pretty mixed up. And you can see how quickly they're migrating along the coast here. And not very many fish make it up to southeast Alaska. So this is the basis of the data. This is excuse my French being Canadian, but this was a hell of a lot of work to put this together. We had to build all of these arrays, keep them in place, make sure that we could make the technical operations work successfully. So, and then the final paper, we have a whole series that I'm going to go through afterwards, or I'm going to show you them. This one was 2013. It was in the Proceedings of the National Academy of Sciences of the U.S. I'm going to mention this as one of the top 5 scientific journals in the world. I'm particularly proud of this, but I'm going to mention this because it's a very highly credible study, but it wasn't cited. And here's the key take-home. After we do all of this work, here is going to be the individual years, and we're going to compare the survival of Snake River smolts 0 to 100%, and the survival of Yakima River smolts going out together, and compare what they are, because the delayed mortality theory says that the Yakima River fish, well, sorry, if it's the same, these data will all lie on the 1-to-1 line. It's just the same survival for each of these groups. If there's delayed mortality, in the years prior to us doing the study, the Yakima River adults came back at 2.5 times the survival of the Snake River fish. And in the years that we actually did the study, on average the adults came back 3.4 times as many as the Snake River fish. So the data point should be up here. Now, here's the data points from releasing them. If we look just at the years aggregated, here's the river up here, quite high survival. The lower river and the estuary, very high survival. The plume, about 50%, 40 to 50%, and then the ocean survival going up the coast, about 10%. But the key point is that all of the data lies on the 1-to-1 line. They're not up here. So we didn't find any evidence of delayed mortality. So the Storch et al. Paper that I pointed out in the review, which did not mention any of this, ignored the data where we specifically tested whether there was delayed mortality or not. Now, in fact, we published 11 papers at this point. This was one of them that I just showed you the key result. We didn't find any delayed mortality. The smolts just had same survival as the Yakima River smolts as they went up the coast. It wasn't suppressed. Now, the journal, Proceedings of the National Academy of Sciences, commissioned a commentary from Professor Ray Hilborn at the University of Washington on this, commenting on the two groups and the big gap between us and whether or not the dams caused an effect or not. But one of my colleagues, Dr. Steve Haysecker, who I have a lot of respect for as a very good analyst, put out a letter to the Proceedings to the National Academy of Sciences saying, oh, well, Welch et al.'s results, that's due to non-representative fishing and ocean migration assumptions. So what he was saying was that we had changed the timing of these fish so that the smolts were released together with the Yakima fish. The Snake River smolts and the Yakima fish went out together, whereas in fact they might have gone out at different timings if they'd been naturally migrating. And also a technical limitation of the work when we did it was that we could only tag and track the top half of the size of smolts. The bottom half of the size was just too small for the tags that we had technically available at the time. And our response here, we said the values controlled scientific studies. What we said is, Dr. Hayesacker's right. We didn't look at the smaller size of the smolts. That's now technically possible. There's smaller tags. But the original delayed mortality theory said that nothing about there had to be a timing difference. It just said that getting beaten up by the Snake River dams was enough to cause this very large additional mortality in the ocean. And we didn't find that. So maybe there is delayed mortality if you change the migration timing or look at just the smaller fish. The smaller fish in particular, we made the point that, there's the data. If the smaller half of the fish had this delayed mortality, and you're getting back 3.4 times as many adults from the Yakima, but it's because the small fish that we didn't tag, all of the delayed mortality was in there, then you'd have to have 6.8 times better survival for the Snake River fish in the really small groups that we didn't test. That was testable. But instead of testing it, the funding was stopped and nobody cites the paper anymore. But they still argue for delayed mortality being an important issue. So we have 11 papers here that were peer-reviewed, none of which were cited. And I'm glad that other speakers have commented on the barging effects. The argument for barging is, the argument for not barging is that by the time the adults come back, the survival is not much better than the in-river migrating fish, the naturally migrating fish that go through dams. In some years it's better, in other years, in the 90s, it was actually a little worse. And in 2010 and 2011, we knew that the results from this, Dr. Haysecker didn't when he was writing his letter to the National Academy of Sciences. But in 2010, we moved the tagging to Bonneville Dam, and we just randomly tagged the fish that were at Bonneville Dam, the bottom dam. We took a genetic sample which was run so that after the fact we'd know which group was from which population. So they were just naturally migrating down. And in 2011 we did the same thing here. And the key point here, again, is that this is mid-upper Columbia River, and then in the ocean survival here. So the same thing that we did before. This is what the return rates were for the years that we did the study. This is what we actually saw as the survival. So these are populations where the survival rates are supposed to be, by the time the adults come back from the ocean, survival is significantly better for various Columbia fish that are migrating in the river than the Snake River fish. But we're finding things are basically one-to-one. We're not finding that Snake River smolts have poorer survival after going through the Snake River dams. They have the same survival over the first month in the ocean. So as I say, despite calling it itself a review, the Storch et al. Authors don't cite any of the papers that we published that said we tested for these things and we don't find any evidence for it. You know, it doesn't mean that it doesn't exist. It just means that our direct tests to try to measure it didn't find it. Now, they did cite one of our peer-reviewed papers, which is one that I recently published in 2020. This is the only one they cited. And this is the paper that we published in 2020. And the one citation that Storch et al. Say, or quote, is, for example, Welch et al. Suggested that most variation in life cycle survival can be explained by marine effects common among populations of Chinook salmon throughout the west coast of North America. I will take you through that data next. But they say, let's see Cope and Botsford and the Independent Scientific Advisory Board. Well, the Cope and Botsford paper is a 30-year-old paper that said that the survival problem for California Chinook salmon is in the ocean, which is what we're saying. And the ISAB paper agreed with us about the nature of our paper, that the median or the average survival was low everywhere, including Alaska. The ISAB did, make the point that there may be a different reason for the explanation for survival being the same. But this is the only citation that the Storch et al. People did to this paper. Now, what they said is most variation in life cycle survival simply isn't correct. This is not what we said. What we said, and I'm going to show next, is that the median or the average survival was the same everywhere. So all the way up to and including Alaska, smolt to adult returns for Chinook salmon is about 1%. It doesn't matter if it's the Snake River dams or not. And my view is that this is a deliberately distorted statement of our paper so that they can ignore having to deal with it. So what wasn't discussed in the Storch et al. 2022 paper? Well, the Snake River spring Chinook. Our interpretation was we agree there's a survival difference with the Yakima versus and the John Day River populations. We agree with that there's a survival difference exists, but not on the role of the dams. We just didn't find the dams had an effect on the early life history survival. Storch et al. Said that the Snake River SARs are lower. If we look at other, I guess it's just this one. Okay, if we look at other mid-river populations, what I'm going to show you is that the SARs is the same as the Snake River, despite there being 4 dams or 8 dams on them. Storch et al. Didn't discuss it. But remember, Storch et al. Formed a large part of the basis for the American Fisheries Society to make these resolutions to take out the dams. Populations outside the Columbia River. I'm going to show you the average SARs are the same as the Snake River. No dams in almost all of these rivers. They didn't discuss it. Some populations have much higher SARs than other local populations outside the Columbia River. This is the Yakima versus Snake River population difference that has been argued to be just due to the dams. They didn't discuss it. And for Snake River Fall Chinook, what I'm going to show you now is that the SARs are actually higher than the mid-Columbia stocks, despite going through the Snake River dams. And again, it's not discussed. So I'm going to step you through this, lots of data. I'm going to give you a very broad overview of this. So, this is going to be tough. All right, on the y-axis, on the x-axis, we've got the coded wire tag survivals for a whole range of populations. This is on a logarithmic axis. For those of you with a mathematical interest, I'm not going to go into that now, but it's basically to compress the data. On all of these slides, we're going to have yearling or spring Chinook here, sub-yearling or fall Chinook. Here, I need to call them yearling because they've been spent a year in freshwater. It's not just all, for hatchery populations, it's not just spring Chinook, because some fall Chinook, which are sub-yearlings, are held in the hatcheries for a year, so we had to be a little careful with our labeling. And we've got hatchery populations in blue, wild populations in gold, and hatchery wild mixtures where that's identified in gray. And then on the right-hand side, we have the number of years of data that's available. This is for Puget Sound, PS. And what I've done is I've drawn the Snake River hatchery survival here. This is all of the Snake River populations that we have data for, collected by the government agencies and published. The number of years of data here. This is the median survival of all of the Snake River hatchery populations. And in gold, that's the median population, median SAR for the wild populations that are reported for the Snake River. So this is not my data, this is just the data that's collected from all of these government-run populations. And let's see, all right. So here I'm going to show you the middle Columbia River populations, Warm Spring, Umatilla, Little White Salmon, Carson, about almost 30 years of data available. Remember, the red line is the Snake River population, median survival, SARS, and there's no difference. All of these populations based on coded wire tag data, the smolt to adult returns are essentially the same. These populations don't go through the Snake River dams. They're somewhere lower. If we step through this again, here's Puget Sound, still in Washington State, but the blue line there is the median survival across all of these populations in Puget Sound. And there's essentially no difference, the blue versus the red line, tiny little difference in the survival. If we look at sub-yearling populations, the middle Columbia River, the blue line's a little bit lower here. So these populations of fall Chinook, very slightly lower survival on average than the Snake River, but almost the same. And here's Puget Sound. It's literally identical. There is no difference with the Snake River populations of fall Chinook versus the Puget Sound populations of Chinook. When I originally discovered this data, I was quite angry. This was back around 2017. I thought we'd made a mistake because we pulled this data for an entirely different purpose. And my comment to my colleagues when I figured out that this was actually real was I said, I didn't know that Puget Sound wasn't in Washington State, because the Snake River dams are in Washington State, and somehow the biologists in Puget Sound couldn't talk to the biologists in the Columbia River and say, yeah, our populations have the same survival yours do. And that was the start of me spending several years on working through all of this data. Here's the Strait of Georgia, up in my neck of the woods. Fraser River populations largely, but not all, some are on Vancouver Island. And you can see that survivals are no different again. So we have all of these populations. By the time the adults come back from the ocean, everybody's got about 1% survival now over the last few decades. And we look at pit tag-based SARS, which is the dominant methodology just in the Columbia now. Here's the Yakima and the John Day populations that the proponents of delayed mortality argue. Here's the Snake River populations, hatchery and wild. And this is the basis for the argument for delayed mortality, because the Yakima and the John Day populations have about 3 times better survival. There's no question about it. What's not discussed is that the hatchery populations from the Middle Columbia River, Warm Springs, Clay, Elm, and Carson don't have much different survival from the hatchery populations in the Snake River. And if we look at the sub-yearlings in the Middle Columbia, coming from Middle Columbia populations, both the wild in gold and the hatchery populations in blue have lower survival than the Snake River fall shark populations. So we are seeing some differences, but the proponents of delayed mortality, who argue that delayed mortality is essentially the reason that the dams have to be removed, point out these two populations with high survival, but don't point out any of the other populations that don't fit the delayed mortality theory. So the claims of substantial delayed mortality underlie most of the conservation arguments for how the Federal Columbia River power system should be operated. However, only two of those populations actually fits what the claim is. So if I want to summarize this, this is the data for the most recent 5 years of data in all of these regions, starting in Southeast Alaska, North Central BC, West Coast Vancouver Island, Strait of Georgia, Puget Sound, the Washington Coast, Lower Columbia River, Mid Columbia River, Upper Columbia River, Oregon Coast, and California. What we did was in each year, each calendar year for the adult returns, we divided the smolt to adult returns for each of these regions by the Snake River SAR for the same year. And we took the last 5 years of available data. And so in that definition, this becomes 1, because it's just comparing with the Snake River as the standard. Whoops, gotta move one more in here. So for the sub-yearling populations, almost all of these regions have lower smolt to adult returns on average than the Snake River. They're below 1 being the Snake River value. So they have lower SARs. So presumably if we took out the 4 Snake River dams, if they're the cause of the problems, then the Snake River sub-yearling survivals will go down by a factor of about 2 to match the SARs for the other populations. So that's nonsensical, of course. If we look at the yearling, essentially the spring populations, they're all just about the same. So Strait of Georgia, Puget Sound, Lower Columbia is a little higher, Mid Columbia is about the same, Upper Columbia is about the same. California is about twice as high, and North Central BC, Southeast Alaska are about twice as high. But the wild populations up in Southeast Alaska are actually significantly lower. In fact, we've got some data since then. I haven't updated that, but it's just about 1 to 1. So in Southeast Alaska, where habitat is essentially pristine or as close to pristine as we're going to get, survival is not any different from the Snake River. So none of this was cited. It was published well before the authors published their own paper, and they chose not to, I would argue, fairly represent it. So the paper by Storch et al. Reviewed the impact of the Snake River dams and formed the basis for the voting resolutions by the AFS and by the governing body, but they completely sidestepped the evidence that the average SARs are no different to most other regions, which means that the dams aren't causing the major problem. They deliberately did not cite the treatment control experiments testing the delayed mortality hypothesis. And that's, direct tests of a theory is considered the gold standard for science. And the calculations of how much Snake River SARs could actually be increased by dam breach in the absence of delayed mortality are tiny. So taking out these dams, yes, it will have some effect on adult returns. There's no question about it. It'll take it from 98% survival per dam to 100% because there won't be dams, but you forego the other advantages of having the dams. Whether that's worth the calculation I showed you in the first slide is a political and social question, but it's not a fish question. So the question is, why are these folks being so obstinate? Well, hallmark of science is that it's supposed to be self-correcting, and I'm showing you evidence that that's not operational in the Columbia River. It's a very emotional issue about people wanting to save the salmon. They want to do something positive. I understand that. Unfortunately, the science doesn't necessarily mean that just acting with your heart is going to be effective. Normally, when scientists are presented with contrary evidence, they show why their colleagues are wrong. My colleague, Dr. Steve Heisecker, wrote the letter to the National Academy of Sciences saying, hey, you didn't tag smaller fish, you changed the migration timing to make everything go together. Maybe that's the reason for it. That's good science. I have no problem with that. Our response is, fair enough, that wasn't part of the original theory, that there had to be differences in migration timing, or that it was just small fish that had this effect. But we can test for that. But there's no interest in testing for it, I think because people don't want to know the answer. And the Fish Passage Center and their colleagues in writing the CSS reports, they only did a bit of A. They show why their colleagues are wrong. They're not actually showing that what they're correct, that what they're arguing for is correct. They're continuing to argue for correlations with certain populations, Yakima and John Day, have higher survival, but they're ignoring all of the other populations where there's data that doesn't show that. They've picked the data that fits the belief that they have, but they're ignoring the data that doesn't fit with their beliefs. There's another important point here. It's being alluded to briefly on harvest. I didn't put this in the main 2020 paper so much. If I was able to show you the YouTube video, I'd make this case a little bit better. But the key point is there's a decoupling between fisheries management and the science that's going on. This is the harvest rates. This is on a log. Harvest rates are here for sub-yearling and for yearling populations over time. The Fish Passage Center in their CSS report stated that harvest rates were about 1%. So they weren't really necessary for taking into account pit tags. For those who know what pit tags are, they're a little don't know what pit tags are. They're a little RFID tag, and they can be picked up at the dams and allow us to measure survival of the smolts down between the dams and the adults back. And I always thought that it wasn't an issue, because if harvest was only 1% for spring chinook in the lower river, it wasn't important. But what I discovered in the process of doing the paper that I just discussed is that the harvest rates aren't 1%. They're up to 20% and 30%. And the reason that's important is that for sub-yearlings, this is the total marine and freshwater harvest multipliers. So here's the harvest rate on the right-hand side, 50, 75, 88, 94%. This is the multiplier. So if you take 50% of the fish out before they're counted at the dams, the adult fish coming back, you should be multiplying the SAR by a factor of 2, because half the fish are missing, and they're not being counted because the catch isn't surveyed for pit tags. If you catch 75%, you should be multiplying the smolt to adult returns by a factor of 4, because only 25% are coming back, 3/4 are being removed by the fisheries. And for the spring chinook here, there's not much ocean harvest, but there's Ocean to McNary Dam harvest, and this is the yearlings and the summer run snake, and it's not 1%, which was be down here and stable. it's large and varying with time. So this really messes up a lot of the pit tag-based survival estimates. The pit tag-based SAR estimates used in the CSS report start in 1998. They assumed 1% survival, and these are the annual estimates, and this is just a smooth curve through it. Here, for example, is the upriver spring Chinook going from about 10% survival up to 20%. These are multipliers of 1 to 1.25. These are big numbers in terms of trying to tease out the effect of dams and spill and flow on the adult returns, which is what the CSS report's about. So, again, this was a mistake. I make mistakes, but what you would hope is that people would correct for the mistakes. And it's particularly important because the pit tag SARs, pit tag-based SAR analysis came online starting in 1998. And in 1999, there was a renegotiated treaty between Canada and the US called the Pacific Salmon Treaty, signed in 1999 for Chinook, and it commits the managers to abundance-based harvest management for Chinook. So what that means is that when abundance is low, harvest rates are reduced. When abundance is projected, abundance is high, harvest rates are increased. Now, because the pit tag SARs are measuring the adult returns, not the survival, they are measuring the escapement from the fisheries. What I've just pointed out to you in the prior slide is that people, in doing their analysis using SARs, they're not taking into account the management and the fluctuations in adult returns that are coming back. They're just taking what survives the fisheries. And the key point here is twofold. First, the fisheries get the benefit of improved hydrosystem conditions. So if the dams are manipulated in a way that's actually positive for salmon returns, the managers are going to let the fishermen mop it up. And this is the real killer. If the managers are really good at their jobs, they're going to try to maintain constant escapement. They want the same number of adult fish on the spawning grounds every year. So if there's a year of bad conditions, they may cut the fishermen back, but in years of good conditions, they'll give the fishermen some extra fish to compensate for the bad years. And if they can do a really good job at that, the escapement to the spawning grounds or to the dams remains constant. So the pit tag system and the SARs isn't measuring survival, it's measuring what the managers are letting escape from the fisheries to come back up the river, and that simply hasn't been represented or recognized. And I gave this talk to the DPA staff in June of 2020, but there's been no uptake on it. There has been no change that I know of. If I could show you the animation, this is on the website. This would go through what I just said, but
rethinking strategies for increasing salmon survival. What do the data say?
I'm actually going to show you just the last.
Rethinking strategies for increasing salmon survival with the nearly pristine freshwater habitats in Alaska. Dr. Welch's team also identified
So we're going to start from here.
called pit tags. However, the team found that the harvest of tagged salmon by fisheries was unaccounted for in past analyses because catches were not surveyed for pit tags. This omission meant that previous studies incorrectly assumed that the amount of Chinook salmon harvested by fisheries was negligible. The Kintama team showed that the harvest of different Chinook populations returning to the Columbia River was large and increasing over time. As a result, the pit tag system in the Columbia River was measuring what escaped from the fisheries and was not just measuring the survival influenced by the dams as originally thought. Lack of harvest monitoring could cause even further problems. Under the terms of the U.S.-Canada Pacific Salmon Treaty, fisheries managers in both countries must allow more fishing when Chinook abundance is high and restrict fishing when abundance is low. This means that managers modify harvests in just the right way to obscure the survival fluctuations caused by the dams. In essence, government managers award the benefit of improved survival to the fisheries, while biologists studying the effect of the dams on salmon don't account for these actions, because the catch isn't monitored for big tags. Therefore, biologists interpret the number of adults coming back to the Columbia River as being determined by the dams and not by the fisheries. This previously unrecognized limitation of the pit tag tagging system is critical to current management efforts in the Columbia River Basin. Fortunately, the Kintama team was able to collate sufficient survival data for Columbia River populations using an alternative tagging methodology to allow the coastline survival comparisons reported in the paper to be carried out.
Okay, so I need to, pardon me. I may need somebody to step to the next slide because I don't seem to be able to do that.
In the bottom left-hand corner, you can see a couple areas there.
All right. That's a big surprise to me because I just gave my thumb drive and it's never ever worked like that before, that it actually worked that way. So the current use of pit tags, the SARs are measuring escapement from the fisheries, the survivors. It's not measuring survival, it's measuring what the adults are coming back from the fishery. And second, the variation in the harvest rates that aren't being incorporated have a very large effect on the impact of how you would interpret spill and flow effects on survival, even if you consider these effects. Because the pit tags are used to calibrate essentially all of the Columbia River Basin model analyses, this variability really, I think, compromises the findings. And I just can't see any evidence that any of the modelers or policy people are willing to recognize this. For example, these different models that have been used in the Columbia River for looking at the effect of the dams on salmon, all of them are calibrated with the SARs that come out of pit tags. The ISAB assessments in 2021 and 2022, following our 2020 paper, said to the CSS and the Fish Passage Center they need to take into account the effects of harvest on SARs. It seemed that didn't happen. It seems the ISAB seems to have given up getting the Fish Passage Center to use it in their analysis. So I found no further mention in the annual CSS studies or the ISAB reports. But in 2024 report that just came out in January of this year, it states, we've made preliminary comparisons of the overall SAR estimates for wild groups to the Northwest Power and Conservation Council 2 to 6% SAR objectives, recognizing additional accounting for harvest, straying, and other upstream passage losses may be needed in the future as NPCC and other SAR objectives are clarified. And this is it. They haven't actually done the analysis. There's no measurement of what's happening here. And Dr. Haysecker, in response to a question from the ISAB, still states the influence of harvest on SARs for spring chinook and steelhead is likely minimal. I mean, it's not. So there needs to be, I've tried to have these debates. Nobody wants to have the debate with me. So I'm hoping that you folks can sort of push the political system to say, maybe David Welch is wrong, but we need to actually have this scientific debate about whether or not these things are actually effectively being used, because right now it's being ignored rather than incorporated in the analysis. Now, I don't have time to go into it now. I apologize for the length of my talk, but this sort of mindset got me to go back to the original studies that identify the cause of the dams as the probable cause of the problems. And what I found from that was that those studies contained fundamental logical errors that have persisted uncorrected for over 50 years. And they really compromise or color all of these subsequent interpretations because people assumed that the dams were causing these problems, and it's made it very difficult for them to look objectively at how much of this is also something that's happening up and down the coast. Even in the Yukon River, which flows into the Bering Sea, this year Alaska Department of Fish and Game has announced that even the Indian ceremonial food fisheries are shut down for the next 5 years. There will be no fisheries at all, including for ceremonial food fish by treaties with the natives, because the runs are so low now. So the consequence of this, of their belief that the dams are a big problem, is that they are unwilling or incapable of looking objectively at the evidence that doesn't fit with their what they believe. So that's my take-home message from that. I hope you can spread the word that there's more than one perspective about what's going on out there, and I hope we have a useful conversation after this. Thank you.